Okay, chapter 2.4, excuse me, solving equations using addition and subtraction. Okay, we have this equivalent equations. This is kind of a vocab, and I've got a little picture of a balance, or maybe a teeter-totter, whatever you like to call it. And when we're solving equations, we have to keep balance. Whatever's on one side is also on the other side if they are equal, but it might look different. Like for instance, we might have x plus 1 on one side, and on the other side we could have 6. So we could imagine that this is a 5, because if x is 5, 5 plus 1 is equal to 6, and it's balanced. What we need to understand is equivalent equations are other two equations that have the equivalency. They're an equal sign, and they may look different, but they're still the same. For instance, on this teeter-totter, if we draw another one, or this balance, we ask this 1 to jump off, like by subtracting it. As long as we also subtract 1 from the other side, it should still stay balanced. And so now, this equation is equivalent to the other one, but it looks different. Instead of x plus 1 is equal to 5, or 6, sorry, x plus 1 is equal to 6, now we have an equation that says x is equal to 5. And they are the same, because if I put 5 in for x and I add 1 to it, I get 6. So we're solving for x. And what we can see here is that whatever we do to one side of the equation, if we do it to the other, it stays balanced. So if I subtract 1 from here and I subtract 1 from here, it's balanced. And that's basically the principle that we're working off. Subtraction property of equality, subtracting the same number from each side of an equation produces an equivalent equation. So as long as we subtract the same number, it's still equal, still equivalent. So they have a lot of simple ones here. X minus 5 is equal to negative 1. Now the opposite of negative 5 would be adding 5. So we're going to add 5 to both sides. It's similar to what we did over here. Now we have x take away 5 plus 5, and if you have a minus 5 and a plus 5, you basically get 0. Those are gone. It just leaves x. And a negative 1 and a positive 5 is 4. And so x is equal to 4. If we put 4 back in here, 4 minus 5 is equal to negative 1. If we put 4 back into the x. Okay, that's how it works over and over again, except that they are going to make it less than perfect by adding fractions and things like that. So if you're not ready for fractions, we need to work you up to that, but I think you are. Z plus 3 halves is equal to 1 half. So z is some number. We're going to start by subtracting 3 halves from both sides. See, whatever we do to one side, we do to the other, and I want to subtract. I want to get rid of this so that z is by itself. So that leaves z, because plus 2/3 minus 2/3 is equal to 0. Ooh, not equal to 3, equal to 0. And 1 half minus 3 halves. Did I say 2/3 again? I keep saying 2/3. It's 3 halves. 1 half minus 3 halves. 1 take away 3 would be negative 2 halves, which gives us 1, or negative 1. Okay? All right. That's most of what we're doing today. You got some story problems that are similar. But add and subtract, get one side off of the other side. See how you can do it. They will throw weird things at you like 4.58. It's just a decimal. It's not really weird. Plus y equals 2.5. They could also put something like this where they have the variable, the letter is the variable, on the opposite side of the equation. It's still the same thing. Okay, q is over here, and over here the y is on the left side of the equal sign, and here the q is on the right side of the equal sign. I want you to pay attention. The equal sign is kind of like that dividing line. This is sort of the middle. And it doesn't matter how many things you have on one side or the other. You could have 10 things over here and only one thing over here. It's still balanced because all of them either add up to, or they equal or equivalent to in some way the other side. So this isn't too bad. but it does look a little different. We still want to get the y by itself. And over here we still want to get the q by itself. So we're going to subtract 4.58. I guess I should have put this line down here. That becomes 0, so it just leaves y by itself, but we have to also subtract 4.58 from this side. And you know, this could take you some work, because you say, well, I can't take 4 away from 2. Well, it's negative 4. So remember, when we deal with negative numbers, I add this 0 here just so that we have the same number of place values. You can start with 4.58 and take away 2.50. You just have to remember that your answer is going to be a negative answer, because the difference between these two, negative 4 is more negative than positive 2 is positive. So when these come out at the end, it's going to be a negative answer. You just have to take the larger number and subtract the smaller from it and keep the sign of the larger one. Okay, I know this is something we have already done. So that solves that problem. Down here, we're going to subtract 2/3 from both sides. And we're not going to worry that the q is going to be left alone on the right side of the equation. It doesn't matter if it's on the right or the left. But 2/3 minus 2/3 is 0. So that leaves q by itself. And then 1/2 minus 2/3. We've got a little bit of a problem there. But we just have to, again, this is bigger than this. Okay, it's like adding a negative. This would be the same thing. And we don't have the same common denominator, so we'd have to do that. We'd have to change it to sixths. Okay, and so 2/3 is the same as, if I multiply by 2/2, 4/6. And 1/2, I'd have to multiply by 3/3. Would be 3/6. Okay, and then 3 plus a negative 4 is negative 1/6. Right? 3 plus a negative 4 is negative 1. So that's what q would be, negative 1/6. We just have to remember that we're still working with integers here and rational numbers. And we have to remember the rules for positives and negatives, and we're just solving for equations using that balance. This will be a good one.